We live our entire lives within a construct, a mental model of the world that our brain builds using the raw data from our eyes. Imagine you are standing in a dark forest holding a single flashlight. As you click it on, a sharp golden beam cuts through the shadows, landing on a tree trunk. To your human brain, that beam is a solid, undeniable fact. It represents a straight line, the shortest distance between 2 points. This is the foundation of what we call classical logic. It is the reason we trust our steps, the reason we believe we can accurately measure the world around us. But what if I told you that this straight line is the greatest deception ever played by the universe? Your eyes were never designed to see the truth. They were designed for survival. They filter out the overwhelming chaos of the quantum realm and provide you with a simplified, user-friendly version of reality. When you look at a mirror, you don't see the infinite complexity of light interacting with silver atoms. You just see your face. You see a predictable world where objects stay in their place and light behaves like an obedient servant. But physics, particularly the work of giants like Richard Feynman, has revealed that beneath this calm surface lies a frantic, impossible reality. You were taught in school that light is a ray, a predictable arrow moving through space. But nature does not use arrows. It uses probabilities. The light from that flashlight isn't just traveling to the tree. It is exploring the entire room, the entire forest, and perhaps even the edges of the galaxy before it finally settles into the image your brain perceives. This isn't just a poetic metaphor. It is a mathematical necessity of the quantum world. We are living in a sea of ghosts where every photon is a messenger from a reality where here and there are not fixed locations, but mere suggestions. To understand the double slit experiment, you must first let go of the idea that your eyes are reliable witnesses. They are storytellers, and they have been lying to you since the day you were born. The straight lines you see are just the average of a billion chaotic paths. To see the universe as it truly is, we must look past the illusion of sight and embrace the beautiful, terrifying chaos of the math. We are about to shatter the straight lines of your logic and enter a world where nothing is as it seems. For centuries, the human mind has been desperate to put nature into neat, tidy boxes. We want to know exactly what a thing is. Is it a solid rock, or is it a ripple in a lake? This binary way of thinking, the idea that something must be either a particle or a wave, triggered a massive identity crisis in the world of physics that lasted for generations. At the heart of this storm was Isaac Newton, who envisioned light as a stream of tiny, microscopic cannonballs. He called them corpuscles. To Newton, light was matter in motion, subject to the same laws of gravity and impact as a falling apple. This view was dominant because it felt right. It matched our macroscopic intuition that the world is made of discrete, countable things. But then came the challengers. Experiments began to surface, showing that light could do things particles shouldn't be able to do. It could bend around corners, interfere with itself, and spread out like a ghost. This was the behavior of a wave, a non-local disturbance in a medium, like sound traveling through air or a vibration moving through a string. The scientific community was split. If light was a particle, it had to have a specific location. If it was a wave, it was spread out everywhere. The two definitions were mutually exclusive. You cannot be a localized bullet and a spread out vibration at the same precisely defined moment, or so we thought. To grasp the depth of this crisis, we have to look at the experiment that destroyed classical logic, the double slit. Imagine you are firing solid marbles at a screen with two narrow vertical openings. Some marbles hit the wall, and some pass through the slits, forming two distinct piles on the back wall. This is the particle result, simple, predictable, and logical. Now imagine replacing those marbles with water waves. As the wave hits the two slits, it splits into two new wave fronts. These two waves then overlap on the other side. Where a peak meets a peak, they grow stronger. Where a peak meets a trough, they cancel each other out. This creates a complex interference pattern of many vertical stripes. This is the wave result. The nightmare began when scientists tried this with electrons and photons, the fundamental building blocks of our reality. They fired these particles one by one, ensuring that only a single lump of matter was in the apparatus at any given time. Logic dictates that a single particle must go through either the left slit or the right slit. If it goes through the left, it shouldn't care about the right. If you fire enough of them, they should eventually form two piles, just like the marbles. But that is not what happened. Even when fired one at a time, these individual particles slowly built up the striped interference pattern of a wave. This result is absolutely haunting. It implies that a single solid electron somehow knows about both slits. It implies that the electron travels as a wave of probability, passing through both openings simultaneously, interfering with itself, and then deciding where to land. It's as if a single person walked through two different doors at the same time and then bumped into themselves in the hallway. Our language fails to describe this because our language was built for a world of either. Or, while the quantum world is a world of both and, this identity crisis reveals that our fundamental labels, particle and wave, are not descriptions of what light is, but descriptions of how we see it. Light is a quantum entity that transcends these categories. It exists in a state of potentiality until the moment it is forced to manifest. We are forced to accept a reality where a thing does not have a definite shape or form until it interacts with the world. This realization shatters the idea of an objective, independent reality. It suggests that at the most basic level, the universe is not made of stuff, but of information and possibilities. We are looking at a cosmic chameleon that changes its very nature the moment we try to define it. If your mind is already reeling from the idea of a particle acting like a wave, prepare for the foundation of your reality to be completely uprooted. We have been conditioned to believe that movement is a linear process, that to get from point A to point B, an object must follow a specific singular trajectory. When you throw a ball, it follows a predictable arc. When you drive a car, you occupy a specific lane. But the quantum world, as revealed by the genius of Richard Feynman, operates on a principle that feels more like dark magic than traditional physics. Feynman's path integral formulation suggests that a photon doesn't just take the shortest path to your eye. It actually takes every conceivable path across the entire universe simultaneously. This is the impossible path. Imagine a single photon leaving a distant star and traveling toward your telescope. Common sense says it travels in a straight line through the vacuum of space. However, Feynman's math proves that this photon is also exploring a path that loops around the moon, a path that dives into the heart of a black hole, and even a path that travels to the very edge of the observable universe and back. It is as if the particle is a cosmic scout testing every possible history and every possible future before it finally lands. You might wonder why, if light is going everywhere, we only see it in one place. The answer lies in the beautiful and terrifying dance of phases. Think of every possible path as having a tiny internal clock. As the photon moves along a path, the hand of this clock spins. For paths that are wildly out of the way, like the one that loops around a distant galaxy, the clock hands end up pointing in completely random directions when they reach the destination. When you add all these random directions together, they cancel each other out to zero. They effectively vanish from our reality. However, for the paths that are very close to the straight line, the clock hands all stop at nearly the same position. These paths reinforce one another, building up a strong signal that our eyes eventually perceive as a beam of light. What we see as a straight line is actually just a statistical average, a calm surface created by the violent cancellation of infinite chaotic possibilities. This means that the vacuum of space isn't empty. It is crowded with the ghosts of paths not taken. Every time you see a reflection in a pool of water or a glint of light off a window, you are witnessing the final result of an infinite calculation performed by the universe itself. The mirror isn't just reflecting light from one spot. The entire surface of the mirror is involved in the calculation. But the wrong paths simply cancel each other out. This realization turns our understanding of the universe upside down. It suggests that the cosmos is fundamentally interconnected in a way that our senses cannot detect. Nothing happens in isolation. The journey of a single electron is tied to the geometry of the entire universe. We often feel like small, isolated observers in a vast, empty space, but the path integral tells us that every point in space is vital to the movement of every particle. We are living in a reality of sum over histories, where the present moment is the weighted average of every possible thing that could have happened. If you find this difficult to visualize, you aren't alone. Our brains evolved to hunt for food and avoid predators on a macroscopic scale. We were never built to perceive the sum of infinite paths. But the math doesn't lie. This theory is the most accurately tested prediction in the history of human science. It proves that the straight line of our logic is merely a useful fiction. Behind the curtain of our daily lives, light is a wild, untamable force that refuses to be pinned down to a single route. It is a reminder that the universe is far more generous with its possibilities than we are with our imagination. By accepting the impossible path, we begin to see the world not as a collection of fixed tracks, but as a shimmering field of infinite potential, where every destination is reached by exploring the entire cosmos at once. Why does all of this matter? Is the double slit experiment just a laboratory curiosity, or does it hold the key to our existence? The answer is that the very solidity of your world depends on these impossible rules. If electrons didn't behave like waves, they would spiral into the nucleus of the atom, and all matter would collapse in a heartbeat. The chaos we've discussed is actually the invisible glue holding your body, your home, and the stars together. We have learned that the straight line is a lie told by our eyes to keep us sane. We have seen that light is a ghost that explores every corner of the universe before deciding where to land. And most importantly, we have realized that we are not separate from the world we observe. We are active participants in the creation of our own reality. The architecture of reality isn't made of bricks and mortar. It is made of probability, information, and the act of looking. To live with a destroyed logic is to finally see the world with open eyes. It is to accept that the universe is far larger, weirder, and more interconnected than our ancestors ever dreamed. The double slit experiment isn't just a lesson in physics, it's a lesson in humility. It teaches us that our intuition is a narrow filter and that the truth is always more beautiful than the illusion. So stop trusting your eyes. Stop believing that the world is a simple mechanical machine. Instead, start trusting the math that points toward a reality of infinite potential. You are a conscious observer in a universe of ghosts, and your gaze is the most powerful force in existence. The straight line may be a lie, but the quantum truth is the greatest story ever told. Embrace the chaos, for it is the only thing that is truly real. Now we arrive at the most haunting question in all of science. What happens when we try to catch the universe in the act? We know that when we aren't looking, light behaves like a wave of possibilities, taking every path at once. But humans are curious. We want to know exactly which slit the electron went through. We want to pull back the curtain and see the truth. So we set up a detector. A sophisticated piece of equipment designed to watch the slits and record the path of each particle. The result of this simple act is perhaps the most disturbing discovery ever made. The moment we look, the universe changes. The very second a detector is turned on, the interference pattern, the evidence of light's wave. Like nature vanishes instantly, the electrons stop taking every path and start behaving like boring, predictable little marbles. They go through one slit or the other, and they form two simple piles on the back wall. It's as if the universe knows it is being watched and decides to hide its magic. This is the observer's paradox, and it shatters the most fundamental assumption of science, that there is an objective world out there that exists independently of us. For decades, physicists tried to explain this away. They thought that perhaps the light from our detectors was physically bumping into the electrons and disturbing them. But further experiments, like the delayed choice quantum eraser, prove that this isn't about physical interference. It's about information. If the universe contains the information of which path was taken, the quantum behavior collapses. Even if we collect the information and then destroy it before any human can see it, the mere possibility of knowing the path is enough to kill the wave. This implies that the act of observation is not a passive process. We are not just spectators watching a play. We are the editors of the script. By choosing to look, we are forcing the universe to collapse from a sea of infinite possibilities into a single definite reality. This raises a terrifying question. What constitutes an observer? Does it have to be a human mind, or is a camera enough? Some of the most brilliant minds in history, including Erwin Schrödinger and Werner Heisenberg, struggled with the idea that reality might not even exist in a definite state until a conscious mind interacts with it. This destroys the classical logic of a clockwork universe where everything is set in stone. Instead, it suggests a participatory universe. We are trapped in a feedback loop with reality. The way we ask questions determines the answers we get. If we ask, "Are you a wave?" And don't look too closely. The universe answers yes. If we ask, "Which path did you take?" and set up a camera, the universe answers, "I am a particle." The nature of reality is not a fixed property. It is a response to our interrogation. This paradox forces us to confront our own importance. If the collapse of the wave function requires an observer, then we are the ones who give the universe its solidity. Without observation, the world remains a blurred ghost of overlapping probabilities. This is the ultimate mind over matter realization. It suggests that information and consciousness are not just side effects of biological evolution, but are fundamental components of the cosmic architecture. We are the ones who turn the impossible path into the straight line. As we stand before the double slit, we are looking at the boundary between the known and the unknown. The observer's paradox is a warning that our desire for certainty comes at a price. When we insist on knowing exactly where a thing is, we lose the magic of what that thing could be. We trade the infinite beauty of the quantum wave for the cold, hard reality of the particle. We are living in a world that is shaped by our gaze, a world that is waiting for us to look so it can decide what to become.